Good afternoon. Thank you for joining today's presentation. I'm Rishitha and my teammate Shruthi. We are here for the presentation and we are the students of BVRITH working on this paper, analysis and simulation of 7 level and 9 level cascaded H-bridge multi-level inverters. So we are mainly focusing on the cascaded H-bridge multi-level inverters. In the ever-advancing field of power electronics, the demand for more efficient and reliable energy conversion system is increasingly critical. Today, we will delve into a groundbreaking development in this arena, multi-level inverters, and explore how they significantly outperform conventional inverters. Conventional inverters have several drawbacks, including substantial harmonic distortions, lower output quality, and their often bulky and costly nature. In contrast, multi-level inverters overcome these limitations and remarkable and efficiency. The effective reduce harmonic distortions, enhance power quality, and higher voltage capabilities. As we explore the details of multi-level inverters today, you will see why they are rapidly becoming the preferred choice for modern power conversion needs. Multi-level inverters have created a new revolution in high power and medium voltage applications in the industry and research. So, this paper discusses the analysis and simulation of 7 level and 9 level cascaded H-bridge multi-level inverters using a mathematical model and simulation tools. The control strategies, including pulse width modulation techniques, are discussed with a focus on their effect of output waveform quality and reduction of THD. The findings demonstrate the superior performance and power quality advantages offered by these multi-level inverters compared to a traditional two-level inverters. Additionally, a passive filter is designed and implemented along with a multi-level inverter configuration that helps to keep the THD within the limits. So now we come to the block diagram. So So now this is our block diagram. Here as we can see that we have taken the DC supply and we have given the DC supply to the cascaded multi-level inverter from and we have used the LC filter. We have used LC filter to reduce the harmonics. As a result, we are getting the AC source as output. So before going into depth, like we have done a few research on the conventional and multi-level inverters. So as our main focus is on multi-level inverters, we'll be discussing about the multi-level inverters. So this is the circuit topology of 7-level cascaded H-bridge multi-level inverters and its corresponding output voltage waveforms. So here we can see the cascaded H bridge is consist of three bridges. So, as this is the 7 level inverters, the H1 is the bridge 1, the H2 is the bridge 2, and the H3 is the bridge 3. So, the voltage produced by each bridge is added together to get the required voltage. The voltage levels produced in these MLI are plus 3 VDC, plus 2 VDC, plus VDC, 0, minus VDC, minus 2 VDC, and minus 3 VDC. That is, here we are getting the 3 positives, 3 negatives, and 1 0. So, the characteristics of 7 level CHBMLI make it suitable for high application that require low harmonic distortion and better voltage control. So, switching operations are used to generate different voltages as given in this figure. So when the switches in the MLI are turned on and off according to the switch pattern, they correspond the voltages and are obtained. Here, the figure 1 indicates the switch is in on state and 0 indicates that the switch is in off state. So as we can see, um, so here the figures 5A to 5H represent various working modes of 7-level multi-level inverters through which various levels of voltages are produced. And the figure 6 represent the output voltage waveform of the 7 levels multi-level inverters. So this is the simulation of the 7-level multi-level inverters which we have made. So as we can see here, this is the output waveforms, and as we can see, so here it is a step waveform and it has 7 different steps. So this can tell us that this is the 7 level H bridge inverter's output.
Okay, so hi everyone, I'm Shruti and I'll be discussing analysis and simulation of 9 level cascaded H bridge multi-level inverters. And our primary focus is on evaluating the effect of different control strategies on the output waveform quality and also reducing the total harmonic distortion. So to begin with, let's look at the 9 level cascaded H bridge multi-level inverter configuration. And on the figure 7, we see this. And we can also see that this system utilizes 4 H bridges and each comprising of 4 switches, so to generate different range of voltage levels. As Similar to 7 level, here we are going to generate 4 positive, 4 negative, and 1 0. So this setup is significantly improves the waveform quality by reducing harmonic content, which in turn minimizes the noise and distortion. So additionally, it offers reduced switching losses and also the enhanced efficiency. The general structure of 9 level CHB MLI and its corresponding waveform is shown here. And as we can see, there are like 9 levels of 9 level of stepped waveform is shown here, and it produces an output of 4 positive, 4 negative, as shown in the figure. And Figure 9 illustrates the switching pattern of 9 level CHB MLI, showcasing how these 9 distinct voltage levels are generated. So, as 0 represents switch is an off state and 1 represents it as an on, and according onning and offing the switches in this pattern generates the different voltages which are combined together to form an output voltage. So here in figures 10A to I, various working modes of the 9 level CHB MLI through which various voltages are produced. So this is how the various voltages are produced, and we are indicating it. So this is the simulation diagram, simulation model of which 9 level multi-level inverter, and this is the output waveform of 9 level MLI. The output waveform features multiple voltage levels as shown, and demonstrating its capacity to produce smoother and more precise waveform compared to 7 level. Uh, and it is also proved that the harmonic content decreases with an increase in level of multi-levels inverter. So one of the important factor to discuss here is the THD analysis of multi-level inverters, as it greatly affects the inverter performance. So basically THD is a measure of waveform quality and it is defined by the harmonic number n. And in the context of multi-level inverters, control switching pulses in the output voltage are used to reduce the THD. And lowering this THD helps to eliminate the presence of harmonics and improves the quality of power delivered. So, according to IEEE standards, the limit is set to 5% and limiting the individual harmonics to 3%. So, as we can see in the figure, the 7 level THD analysis shows 13.82%, and this is the analysis, THD analysis of 9 level multi level inverter, and which is about 12.25%. So, since the IEEE standards are set to less than 5%, we should find a way to reduce these THDs. And all the formulas and techniques used to reduce the THD are clearly mentioned in the paper. And to achieve to achieve to come in complaints with these standards and improve the inverter efficiency, we used filters. So we used an LC filter, and basically filters helps us to mitigate the harmonics and enhance the fundamental components of the output. So we designed and implemented a passive LC filter in our simulation model, and this filter uses inductors and capacitors to shape the filter. And the LC filter, when applied with the switching method, it becomes capable to reduce the harmonics and enhance the fundamental component of the output voltage. After integrating the filter with the waveforms, so these are the waveforms we observed after integrating the filter. As we can see, both the 7 and 9 level waveforms have almost become sinusoidal, demonstrating a significant reduction in harmonic distortion. So this is the THD measure after connecting the filter. So it shows it is around 2.48% and 3.27%. So these values are well within the IEEE limits and confirming the effectiveness of the filter, improving the efficiency of the inverters. So we have recorded all those parameters in a table. So below table shows the variation in parameters like THD values and fundamental component of output voltage for 7 and 9 level inverters. And we can also prove something like upon increase of levels in multi-level inverter, the THD is decreased. So it is 13.82 for 7 level and 12.25 for 9 level. And upon using filter, we have also reached 2.68% for 7 level and 3.27% for 9 level. And we also noticed the significant improvement in fundamental component of output voltage. So, by all these observations, we can conclude that cascaded H-bridge multi-level inverter produces better quality waveforms than conventional inverters. And while working with inverters, PWM techniques are essential to achieve the desired output. Upon considering various factors, it was decided to use the level shift pulse width modulation PWM technique for this project. So, for this level shift PWM, we are using sine wave as a modulating signal, and it is also noticed that the THD percent and decreases with the increase in MLI, and we have also seen the THD values and the fundamental component uh, of output voltage, and we have also reduced the harmonic content by using filters. So, and we also noticed that using filters it reduces the THD value to the set acceptable IEEE limits. So with all these we are able to increase the efficiency of MLI. So these are so I'll give you a quick review of our paper. So this is a paper titled Analysis and Simulation of 7 and 9 level Cascaded H-bridge multi-level inverters. As said, the focus is mainly on 7 and 9 level cascaded multi-level inverters. So this is our abstract. And we have introduced the common conventional inverters here. And then this is the basic block diagram principle that of inverter. And then on theoretical basis, we have did some research on conventional inverters, two-level inverters, and multi-level inverters. Then we moved on to cascaded H-bridge multi-level inverters. And we have also discussed the pulse width modulation techniques and also some multi-carrier PWM scheme. And moving on, we have noted different PWM techniques like sinusoidal PWM and level shift PWM. And as I said, upon considering various factors, we are moving with level shift PWM. And this method part discusses the simulation of cascaded H-bridge 7-level multi-level inverters, and the images illustrate the circuit topology, waveform, and switching frequencies. These are the working modes of 7-level waveforms. And then moving on with 9-level cascaded H-bridge MLI and its simulation, its diagrams, its waveforms, all it's everything mentioned here, and all the circuit topologies, working modes here. And then moving on with the THD analysis, we have mentioned regarding the THD analysis and use the following formulas. Later on, we have compared the two THD analysis of 7 and 9 level um, CHBMLI before applying a filter. And since we have noticed that the THD is more than the IEEE standards, so we have decided to implement a filter here. And this is a passive filter we have choose to implement. And these are the formulas used to calculate L and C, passive LC filter. We have also discussed some type of filters over here. And moving on, these are the waveforms. As we can see, both are almost sinusoidal, uh, which shows that the harmonics are reduced to a great extent. And the THD analysis of 7 and 9 level CHBMLI after connecting a filter, we can see that everything is like documented in this table. You can see it is around 2.68 and 3.27%, so which is according to IEEE standards. And so this is the conclusion. We have noted all of findings in the conclusion, and these are the acknowledgements. And this research was supported by Wuzhong University Academic Research Funding 2024. And these are the reference papers that we have referred and did some research around the multi-level inverters, and also the computation methods we have used to um, used in our simulation and all. So this is our paper, and thank you for your interest, and thanks for your time. Thank you.